Let's discuss the various factors and design consideration for designing the solutions for BCP and DR. Let's unpack the various factors first that you should know of. The list is on the screen. Let's touch upon briefly on each of them. For application and data availability requirements, depending on the acceptable downtime and data loss for each workload, you may advise to implement active-active or active-passive setups to ensure availability and quick recovery. For BCDR and patch services, you advise to use native disaster recovery and high availability features provided by the platform. Solution team should utilize geo-replication for data and services to ensure they are available in multiple regions, provided it is okay from data residency perspective. And solution team should deploy services in multiple regions to ensure performance and failure capabilities. For application operations during an outage, solution team can plan for applications to operate with reduced functionality or performance during an outage. For this purpose, DR and BCP solutions should be designed in advance to support the business applications. For workload suitability for availability zones or availability sets, solution team should consider how data is shared and dependent across zones. They should understand how using availability zones or availability sets affects maintenance and updates. They should determine what percentage of workloads can be under maintenance at the same time and should ensure the required VM SKUs such as Azure Ultra Disk Storage are supported by availability zones. For consistent backups for applications and data, solution team should use VM snapshots and Azure Backup Recovery Services vaults for consistent backups. Be aware of limits on the number and size of the recovery services vault as well. For network connectivity during failure, solution team should plan bandwidth for Azure Express Route in case of hybrid. Network team should manage traffic routing during regional, zonal, or network outages if needed. For planned and unplanned failures, solution team should maintain IP addresses after failure and failback. They should ensure that DevOps capabilities remain functional during and after failures. They should also protect application keys, certificates, and secrets with Azure Key Vault in DR. For data residency, you guide to the solution team to follow in-country or regional guidelines to keep data within specified borders. They should design cross-region replication to meet data residency requirements, considering local regulations such as tax and law enforcement needs. What technologies or design considerations that can be given to design solutions for BCP and DR? Let's explore that here. First one is employ Azure Site Recovery for Azure to Azure VMDR scenarios. Site recovery uses real-time replication and recovery automation to replicate workloads across regions. Built-in platform capabilities for VM workloads meet low RPO and RTO requirements. You can advise to use site recovery to run recovery drills without affecting production workloads. You can also advise to use Azure Policy to enable replication and to audit VM protection wherever needed. Second solution could be use native PaaS DR capabilities. Built-in PaaS features simplify both design and deployment automation for replication and failure in workload architectures. Organizations that define service standards can also audit and enforce the service configuration through Azure Policy. Other solution is use Azure native backup capabilities. Azure Backup and PaaS native backup features remove the need for third-party backup software and infrastructure. As with other native features, you can set, audit, and enforce backup configurations with Azure Policy to ensure compliance with organization requirements. Next solution could be use multiple regions and peering locations for express route connectivity. A redundant hybrid network architecture can help ensure uninterrupted cross-premises connectivity if an outage affects an Azure region or peering provider location. But again, there should be networking design consideration in this case. And the last solution in the list is avoid using overlapping IP address ranges in production and DR networks. Production and DR networks that have overlapping IP addresses require a failure process that can complicate and delay application failure. When possible, plan for a BCDR network architecture that provides concurrent connectivity to all sites. Overall, you as a cybersecurity architect may not design all the elements necessary for business applications, However, you must advise to the solution team about the BCP and DR solution needed, considering the tiering of the application and data criticality. If you are doing a risk assessment on the tier 1 application that is much critical to the business operation, you may want to see primary and secondary sites are active at the same time. Maybe with reduced capacity, but this is what essential to consider, depending on the criticality of the application. Hope now you have a good understanding around BCP and DR solutions in the cloud.